Hopefully, you've all had some ideas and explanations for the double crocodile that we saw in the previous video. To explain it in detail, we need to go and explore some physics. When a ray of light is traveling between materials and it hits the boundary, its angle changes. It bends. It's refracted. The mathematical formula that describes by how much and in which direction the ray will bend is called Snell's law. It's named after this guy, who has a great mustache. Snell's law states that the refractive index of the first medium times the sine of the angle of the incoming ray is equal to the refractive index of the second medium times the sine of the angle of the refracted ray. Both of these angles are with respect to the normal. That's the line that is 90 degrees from the interface. The refractive index of a medium is equal to the speed of light in a vacuum divided by the speed of light in that medium.
But instead of just talking about Snell's law, I want to show you what it looks like in reality, and we should also test out if it actually works. So here we have a green laser that is being fired into the water at a 45-degree angle. Notice how the angle of the ray changes at the interface. In our case, even though the laser enters the water at 45 degrees, it leaves at 32. Pause the video here to see if these numbers make sense. The refractive index of air is 1 and water is about 1.33.
Now let's see what happens when we put the laser into water. Now the laser beam is leaving the water and entering the air at 45 degrees. When the ray of light leaves the water, it refracts the other way. The angle from the normal is now 66.8 degrees.
I want you to stop the video again and see if these numbers make sense.
There is something interesting that happens when you start increasing this angle. After a certain point, all of the light becomes reflected. The angle after which all of the light is reflected is called the critical angle.
After this angle, the laser beam doesn't get into the air at all. All of it reflects back. This phenomenon is called total internal reflection, and it happens to be the key to understanding the double crocodile. If we were standing right underneath the tank holding the crocodile, we would be able to see its head poking up above the water. But as we move around to the side, the angle increases past the critical angle, and so all the light reflects from the water-air boundary. Its head becomes invisible, and it makes it look like there are two crocodiles.
In the next video, we'll talk about the applications of Snell's law in the real world. It's very useful in a lot of industries, ranging from medicine to telecommunications. Also, without this understanding, we wouldn't have lenses, making this video impossible, or at the very least, very blurry.